Okay, we have number 4, we have a repeating linear factor in the denominator. And with repeating linear factors, okay, we're going to go from the first degree of the denominator up to the degree upon which the repeating linear factor is displayed in the original ratio. So we have 4x minus 6 all over x minus 1 squared. Okay, and with setting up partial fraction decomposition, which we have to do in this particular case, okay, for we do not have any usage, where we can arrive to the integral on the basis of the power rule or integration by substitution quite so automatically. And now, so with the partial fraction decomposition of this particular repeating factor, okay, again, we can split up into two fractions where we have the first degree of x minus 1 in the denominator as well as the second degree. And we can set up where we have a over x minus 1 plus b over the square of x minus 1. And as we look at clearing out the fractions, we're going to multiply everything out by the square of x minus 1. So we have, on the left, we have the numerator 4x minus 6. For a, we have one order of x minus 1 will cancel out, but left over is going to be still a remaining power of x minus 1. And then we have b, since this is already over the common denominator, okay, everything here is going to cancel out. So we have 4x minus 6 is equal to a times the quantity of x minus 1 plus b. And there is only one zero that we can utilize, and that is going to be from x minus 1, where we can set x equal to 1. And so it would go ahead and use this 0. Okay, we have setting x to 1. Yeah, 4 times 1 is 4, minus 6 is negative 2. 1 minus 1 is 0, which will cancel out a, and then we have plus b. So we have negative 2 is equal to b, and thus b is equal to negative 2. Now, in terms of solving for a, it can choose most any value, but since we're looking at solving for 1a, okay, we can get from x minus 1a to merely 1a if we set x equal to 2. And so if we choose x equal to 2, okay, we're going to have in the setup, we have 4 times 2 is 8, minus 6 is 2, 2 minus 1 is 1a, and then we have plus b, and b is already a known value, and as we substitute negative 2 for b into this newly formed equation, we're going to have that 2 is equal to a plus negative 2, or 2 is equal to a minus 2, and then upon adding 2 to both sides, the missing value of a is going to end up at 4. And so we have, with the values of a at 4 and b at negative 2, okay, we have with the partial fraction decomposition, okay, that results, okay, we have for a over x minus 1, okay, this will be equal to 4 over x minus 1, and then for b we have negative 2 all over x minus 1 quantity squared, and so we can perform integration where we have the integral of the original ratio is equal to, and we can say 4 times the integral of 1 over x minus 1 dx minus 2 times the integral of 1 over the square of x minus 1 dx. And in terms of the resulting antiderivatives, okay, we have 4 times the natural logarithm of x minus 1, and we have minus 2, and with the power rule of the reciprocal of the square of x minus 1, okay, that antiderivative, we have negative 1 over x minus 1, and negative 2 will be distributed over this, and altogether for our terms, you can write these out in various ways, but for what we have here, you have essentially for the terms, you're going to have 4 times the natural logarithm of x minus 1, and with the negatives canceling out, we have plus 2 over x minus 1, and then followed by the constant.